Hello everybody and welcome to this Royal Academy of Engineering event. Now, I find it incredibly exciting that we're here talking about space, but I realise for you this is the day job, this is what you always talk about. I'm completely wowed, a bit like covering technology. People are amazed by some of the things I talk about that I've covered where I'm that's just a day's work. Right? Yes, of course I did that. How many people do we have here who work in the space industry, just so I can gather yours? Okay. So we've got a few. There's about 6 of you. So there's a very large room full of people here who are going to be amazed by every word that you have to say. Now, with reports that the new Saxaborg spaceport in Shetland will be ready for satellite launches by July this year, it's an exciting time to hear from people who are working at the forefront of space. Let me introduce my wonderful panel. We have Sam Adlen, co-CEO of Space Solar, a company innovating in space-based solar power. Dr. Katie King, CEO of BioOrbit, a startup working to manufacture cancer immunotherapy drugs in space. Anita Burney, Managing Director of MDA Space UK, a company with a long legacy in geointelligence, satellite systems, robotics and space operations. And Professor Craig Clark, a Fellow of the Academy and Professor of Practice for Space at the University of Strathclyde. So, first of all, I'd like to talk solar panels. Solar panels in space. How?
It really is as simple as it sounds, Lara. The whole focus of space solar is about using the abundant solar energy we've got in space to power markets both on Earth and in space. I mean, I'll do the reasons you do it first. I think that provides a bit of context. So the first reason is the sun always shines in space. So in a high Earth orbit, you see the sun 24/7 and gives you that firm baseload power that the grid really needs to work. The second reason is its scalability. So our CTO's come from the world of fusion. He believes fusion will work, but the economics and how that evolves in terms of number and magnitude of systems you can deliver, he's not so sure about. Whereas space-based solar power is comprised of hundreds of thousands of these solar panels, so you've got mass production economics. You can put up tens of gigawatts a year. It's really sustainable. So about half the carbon footprint of terrestrial solar, and you can use about 8,000 times less rare earth minerals, which is hugely important with the mining and minerals challenge we have ahead. And then the thing I really love is its flexibility. So again, high Earth orbit, you can instantaneously switch the beam between points of the field of view. So Imperial College, who did a lot of the energy system studies for the UK government, just 2 gigawatts of space solar power saves over £1 billion a year in energy system costs just for the UK. It's quite incredible. So to your question then, it really is as simple as it sounds. It's large solar arrays up in space, and we do that because you see the sun all the time, and because you get, for the UK at least, you get 13 times more instant energy. It's those two things that then drive the economics. So then, up in space, we convert that energy to high-frequency radio waves, things we're all pretty comfortable with through satellite communications or radar. We're all comfortable that a radio circuitry can drive an antenna and produce transmit electromagnetic waves. At the other end, the receiving antenna, then it's just a simple diode-based approach to rectify that, turn that into DC current. And
I love how simple you're making this sound, but wow, how do you physically get it there? How do you physically get it working? This is a major feat of engineering.
It is an engineering challenge. Actually, I think that's one of the nice things about it. The physics is completely understood. And then it's about engineering the economics. So we've just completed a design study with the Space Agency and Department for Energy, and it looks really good. We're at concept maturity level 4, so we know that at subsystem level, and I can see a couple of partners in the room, we can build this. And it's about then how you engineer it. So in terms of how you get it into space, I think that's one of the exciting things for people who are new to the space sector today in the audience. We're about to see a huge step change in the space sector with the onset of Starship and heavy reusable launch, which has already, the launch costs have dropped 2 orders of magnitude since the days of the space shuttle. We're about to go on a huge step change. 100 tons to GEO he says $100 per kilogram, which should be an order of magnitude from where we are today. We may not get there, it may take a long time, but we're going to see a huge step change that allows concepts like space-based solar power to be realised.
This idea of a step change or just a huge turning point, all of you kind of nodded to this, that we're obviously at a point where things are going to get even more exciting. We, of course, go to space to learn more, to make things better on Earth, as well as to explore space. Anita, do you want to just talk us through some of the things that we have already found have been possible and where we might be heading in this amazing moment?
Well, we're living in this era where everyone is now realising how critical space-based and space-enabled technologies are for our everyday lives, for economic prosperity, for our safety and our security. It's woven into everyone's lives. I don't think anyone who managed to get here today would have got here without the benefit of space technology. And so this next wave of activity that's happening in the economy is about helping to increase the levels of connectivity between people, make the world safer and make the world healthier. And some of those initiatives are being driven from within NDA space across a number of areas. One of the key ones at the moment that's driving the economy forward is all around satellite connectivity, everything becoming increasingly connected with everything else. This is really important from a socio-economic perspective, because if you're not connected, then you're not part of the economic productive society. And so there are areas in the world that you simply can't reach through terrestrial systems. And so satellites are being used to bridge that gap and bridge that digital divide that exists. And so that's really exciting. And to Sam's point around having larger launchers, we are now in the position where we can launch much larger satellites, which are increasingly digital. So in the old days, you'd see these photographs of satellites with these massive kind of thick dishes, and you'd launch them, you'd spend tens, hundreds of millions of dollars and pounds on them, and you'd launch them, and that would be it. They would be done, and you couldn't change them. If the market changed, if your customer needs changed, you would be stuck flying this satellite that maybe didn't support the needs of the emerging market. Now we are moving to this digital satellite age where you can launch a satellite, you can reconfigure the capabilities to suit where you want to send your signals and send your communications, and also adjust to your market needs. So that's something that's really helping to drive the industry forward.
There's so much to unpack there. And something you said earlier on that I thought was really interesting was how much of our everyday life we require space technology. And a bit like, certainly several years ago, I don't think people really acknowledged how AI was built into so many areas of our lives. Do you think people have any sort of idea as to how important things going on in space are for us all day, every day?
Sadly not, and I think it's because we don't see them every day. We build them, we put a lot of time and effort and technology and effort on the ground to launch them. They're usually manufactured in a relatively secure facility that only the people who work there get to see. And then we launch them. They get shipped to a launch site, we launch them, and they're a minimum of 600, 700 kilometres above the Earth, never to be seen again. And so to make that kind of physical connection with the capability, I think it's really hard for people to see. But I think if we were to turn it around and think, what would a day in our lives be like if space did not exist? Then I think that we would all start to feel the pain. I suspect that anyone who got here with their just tapping in and out of public transport, that all relies on the global navigation systems, all the timing for transportation, just our everyday lives and getting Ubers.
Yeah.
Everything relies on knowing where we are and knowing what time it is, and that capability is all carried by space technology, and that underpins everything.
And Craig, for you, getting access to the data, finding different ways to be able to bring back the information we need is kind of central to the CubeSat idea, isn't it? Do you want to just talk us through a little bit what it is?
Well, CubeSats were primarily an idea to kind of standardise a satellite size. They're quite small, but based on a 10 centimetre cube. So you could have a standard subsystems, standard launch systems, standard pricing to launch your satellite, but then lots of different payloads. And by making things standard, it really reduced the cost of systems. So I started a company called Clyde Space, and we made standard subsystems, and we eventually started making satellites. But we were selling parts of satellites all over the world to universities and to other companies and different organisations, so that they could build their satellites a lot more cost effectively, get them to orbit quicker. And so we were productionising these systems, then the satellites themselves, I think that's going to be the future. So we're seeing it with Starlink. There's no way that Starlink is being produced in a similar manner to what we used to make spacecraft. It'll be a production line of satellites, probably with an acceptable failure rate, which is, I don't think the UK Space Agency would sign off on, in my opinion, but there's probably an acceptable failure rate of the thousands of spacecraft that SpaceX are launching up. But we are changing the way that we design and build satellites, and there's been a lot of engineers in the room, lots of electronics engineers probably. Space isn't as frightening as maybe what you think it is. Space is an environment, so you design your electronics to survive in an environment just like you would with any system. And Anita and I work together at Study Satellites, who are kind of pioneers in this area, and we've used commercial electronics for space for a long time. So basically CubeSats are commercial electronics in a box up in space.
And
Not a
creating
very
them in
big
a
box.
uniform way is making it more affordable and possible to do more. Can you give us a few real-world examples of what has become possible since the CubeSat?
I think my favourite example, there's lots of examples, but one of the missions I worked on was a NASA mission with the University of North Carolina, Wilmington, and they were doing ocean colour monitoring, so you could see silt levels, pollution around coastlines, things like that. The data they were getting previously were from satellites about 400 kilograms plus. We replaced a satellite that was about, I think, 400 kilograms, something like that, called MODIS, with a 4 kilogram satellite with more advanced electronics. We added a spectral band, so it was a multispectral imager. The data and the resolution that we got back from our satellite compared to this other satellite was I don't know the exact number, but at least 10 times better, much higher resolution, much bit more information about what was happening. And I think that's a great example of the moving faster with space systems and taking advantage of the advances in electronics that we've got in the ground. So Moore's law, doubling the number of transistors per chip every 2 years. You know, we can take advantage of that and get more out of space by doing things quicker. I think that's what we're seeing there.
Yeah, there was a company I filmed with a couple of years ago, SatView it was called, and they were mapping the temperature of the whole of the Earth for pollution. So something like that, is that something that would only have become possible in recent times? I mean, that must have taken a bit of a breakthrough to be able to do that. What is it that makes those sort of things possible to be able to bring back that kind of data?
I think Anita would probably better answer that.
Well, I was going to say that the capability has always existed, but I think what's changed now is the increasing commercialisation. To Craig's point around the approach taken to use more commercial off-the-shelf components and to have a more commercial and agile approach to how we build what used to be just the remit of national space agencies and governments, to find a different way to build these missions. I think those two things, like commercialisation, miniaturisation, and a different attitude to your overall risk on a programme, is enabling you to do things that other organisations might historically have shied away from. And now we've been through this several cycles of proving that it can be done very successfully. And now the entire industry thinks about new space. I mean, we did new space before it was even a word.
30 years ago.
So
It's not new anymore.
now it's
Wow.
just commonly accepted.
Yeah.
That's the new way of
You want to add something?
Well, it's the cost point that you're making, and then the volume. So I remember my background was remote sensing a couple of decades ago, and when I was at the Sat Applications Catapult, which does a lot of innovation towards observing the Earth and other things. When we first started in 2013, if you get an image once a month, you'd be quite pleased. Now, because of the costs and the number of satellites that are put up, your revisit time is fantastic. I was overhearing a conversation the other day from someone saying they're pretty close to getting an image every half an hour now, which is just incredible.
This is amazing. What used to be possible? How did it used to work? How often would people get images in the past?
Well, once a month if you're lucky.
Right, okay.
Yeah.
So that's a huge step forward. Now,
Yeah.
Katie, last but not least, absolutely fascinated by what you're doing. You are developing medicines in the microgravity environment that is space. How and why?
Yes, sure. And great to be here. Thank you, everyone. So we are building a pharmaceuticals factory in space to change the way in which cancer treatments can be given to a patient. So this is really a materials science problem that is used in a biological application. So it's all about crystallizing these drugs. And crystallization is a process that's superior in a space environment compared to on Earth. And that can be used across a whole wide range of materials like semiconductors, making more efficient semiconductors. But when applied in a drugs environment and you get more perfect crystals of these drugs, fundamentally you can then take a drug that usually you have to inject intravenously and turn it into a drug that's really highly concentrated that you can then self-inject. So the end result is you don't need to go to hospital anymore. You can stay at home and self-inject the treatment. So it can really help to decrease that burden on the healthcare system. But you need space to get that quality of crystal that makes it good enough for pharmaceutical use. So that's where we're working.
So how is it then okay when it's brought down to Earth to use?
Yes, so crystals are like the most energetically stable form. So once it's in its crystal form, when you bring it back down, then it stays in that shape. It's not like a big, fragile crystal. It's tiny, tiny microns. So we're making really, really tiny crystals so that you can form a little suspension of it. So it's not like having a huge, fragile thing. So yes, it will stay in its form on return.
And how is this practically done? There are no people going to space for this.
Well, for us, we're building an automated system because astronauts are very expensive, turns out. So we're building it so that astronauts aren't required. And so it's very much bridging the science and the engineering. So what I love in our team is that we've got scientists and engineers, and they have to communicate, but communicate well so that the science needs are then met, and then the system is then built to ask those science questions and be able to answer them. So it's a really, I think, cool interdisciplinary aim and goal.
There have been some other medicines that have been investigated in space because of the cellular change that happens there, haven't there? Have you been involved in any of that? Does any of that play into what you're doing? Is there any kind of connection? Because pharmaceuticals in space... there's a lot going on in that area, isn't there?
So we're looking at manufacturing. So again, it's that material science problem of making these crystals on a mass scale and that they're all uniform. So that's our challenge. But generally, life science and health experiments in space are fascinating because if you take something that's evolved always under the presence of gravity and then you take it into a microgravity environment, gene expression starts to change, aging happens faster, disease modeling is accelerated. So if you can develop a drug in this environment that can slow down certain disease progression, then the idea is it can slow it down on an Earth rate too. So it's a very interesting space to look into, but we're manufacturing.
Okay, and we know from AI drug discovery, obviously completely different, but it's often described as looking for a needle in a haystack. My analogy here is, because I don't want to be offensive in asking you this question, how likely is it you're going to succeed?
The science behind crystallization is known. So that's been done on the space station over the last 2 decades. Our challenge is building the hardware that can scale up this production in line with how infrastructure is changing. So I think when we're saying that we're on this step change, that is opening up this in-orbit manufacturing sector. It's never possible before, too expensive. The cadence was too infrequent, but it's changing or about to change. So we're building the hardware to use that infrastructure piece so that then scale is possible.
How do you go about building hardware for space? Craig, this may be one for you. I love on this panel the most amazing things are being mentioned in passing, but they all sound like quite incredible feats. How do you go about creating something that is going to survive the challenge?
Well, there's different ways to look at it. So we mostly design spacecraft for low Earth orbit, and it's actually a fairly benign environment, but you do go from about -40 to +80 degrees about 16 times a day. So that's the challenge on the outside of the spacecraft. There is radiation as well, so you're in a vacuum. So if you have heat generated on board, you need to take that heat away in a different manner you would on the ground, because you can't just blow a fan on it. There's no air to blow on it. So there's all sorts of challenges around that. You also have things like you can't use certain materials because they'll go whiskers and cause short circuits. So like different types of solder you can't use. So there are material challenges as well. So as long as you take into account all of those things, it's not that difficult. The biggest problem is surviving launch. because different launch vehicles are different vibration environments. And if you can just get your thing up there without it falling to bits, then that's probably half the battle.
Well, yes, and the idea of what failure is and how often failure happens and what you learn from it all seems quite interesting to me. Last night on the news, did anybody see the launch, which apparently was a success, but when you saw the pictures, it may not have looked obviously like a success because it didn't last very long, but they collected the data that they wanted. And I have been told by my panel that this is a success and I should talk about it as a success, albeit the pictures seem to tell a different story. Because someone just explained to me, you sort of expect a certain amount of failure, don't you? What's expected? What do you consider a failure or success where it doesn't seem obvious? Because last night's incident didn't seem very obvious to me. Who wants to take this question?
Well, I think it's not just the domain of space where failures happen. You know, we're all trying to be innovative in what we do and do new things that haven't been done before and address different challenges. And so that does require you to extend beyond your comfort zone to try new things. And so your perception of risk is really related to like how far and how fast you want to go and how many iterations do you want, you know, how many little steps do you want to take to get to the end goal. You look at someone like Elon Musk, he's quite content to take quite large strides and move a lot of things forward all in one go, whereas other organizations in space and outside of space are more comfortable to make smaller, relatively small incremental steps. So, and you see the entire spectrum of risk appetite across the space industry, depending on where you are.
But it's the work of Anita and Craig at Surrey Satellites and then Craig at Clyde Space and others that really changed the risk profile for space with these small satellites initially. So you typically, historically, you would design a satellite to last for as long as you could, because once it's gone, it's gone. You couldn't. You will be able to in the future. You couldn't do much with it once it had gone. Taxpayers' money, all that kind of thing. It needed to work. But what happened with CubeSats and the consumer electronics angle, it meant that we could iterate. It didn't matter so much if we lost something. And with what Elon Musk has been mentioned has shown us with SpaceX is that different approach, that we did it, we learned something, we go again. It's incredibly valuable. It applies not just to space, as you say, Anita. And I really hope that with the fantastic engineers in this room, we can adopt that for the future of the UK.
And that data is really important. A lot of data is collected along the way that's meaningful.
Absolutely. You know, I think going back to SpaceX again, I think they really did lead the way in just getting tons and tons of telemetry and trying to understand what the data was telling them that they could then put back into their systems when they're going for the next iteration of their designs. And that's something that I think most of the space industry tries to do as well. I think that the challenge is around the fact that space is quite an expensive business still, even though the costs are coming down, and that there is a high upfront cost to develop your ideas and develop your missions. And often it can take half a decade, even longer sometimes, to get to the point where that mission is ready to launch and it's going to generate returns or benefit for our citizens or for consumers.
The pressure on it when it's actually happening. I mean, how do you feel with what you're trying to do? How do you feel about the pressure at that moment where you're about to go for it?
I mean, the pressure's high because you put the pressure on yourself. You want to succeed and you want to do a brilliant job. I think when it comes to failure, this is just kind of how I live my life, is that failure is only a failure if you don't learn anything from it. And so I think that really applies to this. It's like you obviously don't set out to fail, but if it goes not how you want it to, then you really need to learn fast and adapt quickly. And I think that's okay, what went wrong? Why was that something that was completely out of our control, or was that something that we could have addressed? And if we should have addressed it, then why didn't it happen? And it's like just being really critical and analytical about it so that you don't make the same mistake again.
Yeah, and these are really bold ambitions of what you want to do in space. You're looking for a kind of better cancer treatment. You want to harness solar power. What sort of other ideas are there out there that could really make such a huge change for humanity that people just may not be aware of?
Well, are we about to go, Sam?
Go on, go. I have to.
One of the things we haven't talked about yet is the power of robotics in space. And to touch on something that Katie said about astronauts being expensive and Craig talking about designing our systems for the space environment, humans are very soft. We don't do well with big thermal swings. We certainly cannot breathe in a vacuum, and radiation is not great for us. So the use of robotics to create repeatable, reliable systems in space is becoming increasingly important. The sorts of systems that Sam is talking about implementing in space, there's a limit to how big those systems are, but even though rockets are getting bigger, there is an ultimate limit, and there will be the need for robotic systems to help to assemble systems in orbit. So that's one of the next key areas that I think is going to help to drive the future of the in-orbit economy.
100%. I mean, for me, the next era in space is about large infrastructure.
Yeah.
And all that can do for Earth. It's fantastic to be on a panel with Katie, and great to see huge economic sectors from the Earth now participating in space. But that large infrastructure, it's data centers, space-based solar power, direct-to-mobile communications, everything we can produce in microgravity. And then it's our adjacent economic sphere. You know, it's almost by definition, with everything that's happening, that space is going to have lots of the solutions, or at least part of the solution for things we need moving forward. And then, move that forward a little bit, you've got things like asteroid mining. So I still think that's a little way out. I'm of the view that thanks to some of the incredible people that have worked in space, we're really good at putting very capable things into space. We're actually pretty rubbish at space at the moment. And the change we're going to see over the next 5-10 years is that we get good at space. We can move around, we can build this large infrastructure that Anita's talking about. So our systems, ultimately, they're kilometers in scale. But they're completely different. They look nothing like a spacecraft. They're incredibly thin, and it's amazing. There's some of the engineering challenges and innovations that are going on there. Once we do that, though, because these systems are building a hypermodular, innovation's a numbers game, learning's a numbers game, we'll be good at space. We'll go get some, asteroid mining starts to become, we'll do that. So space is going to be hugely important for us in the next decades to come.
We always talk about the space race, but is it really a competition, or is there some working together? What's the reality of this? Because it's one great goal for mankind, but does it feel like that?
I'd say space is a team sport. When I think about the work that we do at MDA Space, we like to team and partner with other organisations where we can all bring the best of our capabilities together to address our customers and the citizens' needs. And I don't think there's a single organisation out there that can do everything by themselves. Most large space organisations have quite considerable supply chains where we have a whole team of international friends who are all coming together to create the capabilities we need to put these systems in place. And I won't deny, of course, we want to compete. We want to be the ones who get to lead these missions. And so, yes, there's a healthy amount of competition in there, because we all want to be the ones who get to drive these opportunities forward. But there is a huge amount of teamwork to make this happen. A lot of the more exquisite missions, they take a lot of investment, a lot of time. And companies and nations can team together to share the costs and then also share the benefits from those as well. And I think one of the key areas where we're seeing that happen at the moment is with lunar exploration and going back to the moon. And you look at the number of nations that have signed up to the Artemis Accords, it's over 50 now.
Wow.
And they all want to be part of contributing to this future goal of it becoming an interplanetary society. And so, yeah, it's very much a team sport.
In terms of exploration, what's next?
Oh, well, I don't know. Does someone else want to answer that, or I can go?
Yeah, I'm more on the comment.
Could I come back to Anita's point?
Yeah, of course you can.
Review. I think so. Space is a military domain, and there is international collaboration, but it's becoming less. And I think we've mentioned SpaceX a few times. SpaceX and Starlink are trying to dominate the sector with what they're doing, and that's a real danger for the whole of the world and the whole of the space sector. I think it's really good that we're having the whole value chain in the UK, so we'll be able to design and manufacture the spacecraft and the payloads, launch them from the UK and get the data down and process it. So that gives us a full capability, especially in a changing political landscape where we're not sure what's going to be coming next. And let's not talk about politics, but it is quite a challenging time at the moment, and space is extremely important to understand what's happening on the ground. So the UK needs to make sure that it's in a good position. And even though we're friends with our international neighbours and our European neighbours, they're making moves to put infrastructure in place to basically surpass us in the capabilities to build spacecraft. So we need to ensure that we are perfectly placed to build on the great work that's been done till now, so that we can compete globally and make sure we've got jobs and capabilities in the future.
I think I'd also add on to that. So we're a startup, so a much smaller company, and it is competition for funding, and it can be, where do you get your funding from? What geography do you get your funding from? Where is the money available? And that can really change your trajectory as a company in terms of where you end up setting up. So where can you get funding? Because you need to make decisions for your company's survival. And so that might mean moving. And so I think that, yes, there is competition, because in the US there's a lot more investment going into these. And if we're seen as being riskier, there's more investment going in there compared to here in Europe. It's changing, but it's still it's a big difference.
That's a really interesting point. Sam, what's your experience of that been?
Well, I think competition with the US bit or the competition bit.
Well, both bits.
Sorry, the competition bit. I mean, it's one of the most powerful forces on the planet, and actually, it can be a really good thing. It underpins the best of capitalism in some ways. The sort of speed and benefits you can get. But Craig's bang on. It is now at least a bipolar, if not a multipolar environment in space. I'm of the view that wind the clock forward, and by definition, space will bring us all together. It's like I used to have rivalries with my sort of local town at rugby, and then it's sort of then counties, and then with nations at the moment still not getting on. But space will, as you zoom out, space will bring us together. And there's a huge sort of underpinning fabric of people that want space to be good for everyone. But we've got to be pragmatic about where we are today. To the US question, I mean, deep pockets, they get lots done. It remains a challenge for the UK, and as Craig knows, I've mentioned the satellite applications catapult already. But when we set that up in 2013, UK's great at starting things and not so great at scaling. And sadly, however decade or so on, we're still talking about the same things. I'm really hopeful. I am an optimist. I'm hopeful that some of the geopolitical changes recently can actually be a good thing. Who knows quite how they'll settle down, but it feels to me like it's given a shot in the arm to both the UK and European policymakers that they're actually going to back themselves a bit, not wait to be told by someone over there that it's okay for you to do that or invest in that. So I think it will hopefully drive some ambition. And frankly, we need to get into a positive feedback loop. We've been in this negative feedback spiral for decades. We're just gradual decline. We've got to invest enough in things that are going to grow that it turns into a positive feedback loop. There's so much potential in the UK, and space. Well, we're an island nation. Actually, it's infinite up there. Come on, it's a no-brainer to me. I confess to bias, but space should be right at the top of the agenda for the UK government.
Yeah, well, great to see the optimist.
No, not at all.
In which case, we're going to be optimistic, we're going to be ambitious in terms of exploration. What next? Let's go back to this, because we went to touch on it and then we sort of diverted a bit. But what are the ideas as to what we might want to do next?
I think we're still on that journey. So I talked about lunar habitation. We're just at the start of that now. The second half of this decade, we're going to see the first signs of not necessarily permanent habitation of the moon, but we will start to see settlements appearing. So the first landers that land, they will be the first habitats that are used by astronauts on the surface of the moon. And gradually the space economy will emerge around them. So all the things that we need that got us here today in terms of telecommunications and navigation, we're going to need those on the surface of the moon as well, to know where we are and to be able to communicate back to Earth and make sure that we're getting the information we need and that we're able to send scientific data back. So all of that also needs to be developed alongside the fact that you can actually get boots on the moon. How are you going to keep them there is
how far do you see this expanding?
When you say how far, sorry.
I mean, the idea of any sort of habitat on the moon is quite wild. I mean, do you think that this is going to grow? Are lots of people going to end up there? What sort of scale are you seeing this playing out at?
Well, we're seeing nations around the world, in terms of the number of missions that are being planned to the moon, it's in the many hundreds now across the world. And you can kind of plan them out and look at the different missions that are in the conception stage, if not necessarily in the implementation stage. There's hundreds of them. And each of them over time is going to need a more permanent infrastructure there. Otherwise, you have to take everything with you every time you go. And so there's a lot of benefit to trying to establish the basics that you need there that enable us to drive down the cost of the future missions. So there, I can't see an end to this. It's just going to start.
So what would this mean for food, say?
Well, I'm going to have to turn to Katie for some of it in terms of food and medicine. But, all of that needs to go with us in the early stages. And then we need to figure out, there's whole groups of people who are looking into how you grow potatoes. It's all about potatoes. There are so many experiments that are going on the International Space Station around exactly that. Trying to grow a plant when it doesn't know which way is down for its roots, for example, all of that sort of thing is really important to understand. And okay, we might be a little bit more gravity on the surface of the moon, but that's what you need. Plants, they need gravity and they need light. So we need to figure out how we can do that in an environment where the only thing we can probably get that we can use is water. We'd have to take everything else with us.
Do you envisage it being safe for people to take a trip to the moon? I got invited a little while ago. A Japanese billionaire with some tickets invited me. Yeah. I wasn't going to risk leaving my family, but how it's not safe.
Totally do it, to be honest.
Well, look, if anyone's going to do it, I think people on this panel may be quite willing. Look, of course, it's an incredibly tempting idea, but then I think many people would really be terrified by the risk. What would the percentage survival be likely to be? I have no concept of how dangerous this would be.
But I don't think people have really got their heads around how much the space sector could change in the next decade. I know Elon Musk keeps coming up quite a bit, but it is a good example. And actually, it's the important thing to take away is that the fact he's doing it is triggering others to do it. So heavy reusable launch will proliferate across nations. Yeah? He's talking about 1,000 starships. 1,000 starships, yes, predominantly for Mars. So we'll see how the Mars-Moon sort of dialogue and debate goes. But again, innovation's a numbers game. Once you've got these starships going up regularly, there's some incredible planetary physicists, scientists out there. And the ways we can evolve in the next decade or two is absolutely incredible. And if there's a takeaway from today, it's just the rate of change in this sector is just something people just haven't got a handle on.
What do you see? If we throw ahead to 10, 20 years' time, what sort of huge differences do you see taking place? You've got a whole factory there.
Oh, yeah, maybe two. Yeah, I think for me, I'm very much looking at low Earth orbit and the use cases of low Earth orbit in terms of applications and manufacturing. So I don't know much more about further afield than that, but I think that we'll see a lot of manufacturing facilities in space. I think that we'll see a lot of astronauts who have to go and maintain those factories. So, in my head, we'll have several hundred people, and that's probably actually a lower end, who are just working, maintaining all of those facilities in space.
And you talk about what you're doing being a material science issue. What else is being done in this sort of area? Is there other stuff being developed that would fall into the same category?
Yes, so I'd say a company called Spaceports. So they are manufacturing semiconductor chips in microgravity. So again, it's that same benefit of a microgravity environment, and also for them, the vacuum of space makes it much cheaper and cost effective to do these chips in space versus on Earth. So it's really, really exciting. And so the way that the infrastructure is changing means that then you can have these factories.
Okay, so even with I'm going to call them shipping costs.
Yeah.
They're clearly not shipping costs. Even with that included, it could be cheaper to make them there.
Yes, you'd have to ask Josh about it for all the details of the numbers.
Yeah.
But yes.
It's a cost versus quality thing. So you get higher quality semiconductor out.
Okay, so if we have anybody here who is interested in moving into the space sector, what would you say to them? Each of you. Let's go through each of you here. Katie, let's start with you.
Yeah, sure. So I'd say you have to go for it. You have to meet people and find out where the opportunities are. So I'm a scientist as my background, and then moved into the space industry about 2 years ago. And so, yes, it's about meeting the people, finding out more. If you have a vision, then working to make it happen.
And for you, Craig?
Yeah, my recommendation would be to specialise in one of the disciplines that are needed for space. Not necessarily study space. That'll come later. You have to learn it on the job. And also join a startup. If you join a big company, you'll be pigeonholed. But if you join a startup, you'll have to do everything. Choose a good startup, obviously. But we were lucky enough to work in a small business. When it was I joined was at 20 people, and you get thrown in at the deep end. You have to learn on the job, and it's the best induction into a sector. So don't think you need to study space at university. That's definitely not the case. Study something you enjoy and utilise it in space.
Anita?
I was going to say something quite similar to Craig, actually, that I think in the good old days when we first started, it was you needed to have an aerospace engineering degree or an electronics degree, or you couldn't be part of, or astrodynamics PhD, otherwise you couldn't be part of the space industry. And what we see now is that as the applications of space has grown, the whole ecosystem for space has grown. So it's not just about how you build the infrastructure in space, it's all the downstream applications that come with that. So it's, how do we use the data? How do we use that to connect? So you were saying, Sam, around connecting directly to our smartphones, direct to device, and how we use those applications and how we take our terrestrial knowledge and spacify it and vice versa. And so my advice is just do what you're passionate about. There is space for everybody in the space industry, whether it's space-based or space-enabled. As I said when we opened this session, space touches every part of our lives, and there is a way to get into it for everybody. And the more diversity that we have and the more different ways of thinking is going to help us to keep moving forward at pace. Sam, what are your thoughts?
Well, I think it's hopefully come out in the discussion, but I'm sure someone will prove me wrong now, but pretty much every sector terrestrially is going to have a role in space. So if you are in the space sector, whatever you do today, it's almost certainly applicable in some way, be it these sort of things like Katie and I are doing, that developing things for Earth, or if you think about the things humans are going to do more and more of in space, and you get the food and the clothes. I'd be surprised, of course there are, but there won't be many things where there's not applicability to space. Now, I know this isn't a STEM audience, but one of the best pieces of advice I was given growing up was it's like an ice hockey analogy. Sort of skate towards where the puck's going to be, not where it is today. And you want to skate towards, career-wise, where where a sector that's going to be peaking or growing when you hit the peak of your career in 30 years' time. That is space. There's so many. Well, we're in the time of probably greatest change ever, which is really exciting. People are going to have to continually reinvent themselves every 5 years or more, potentially. Space isn't going to go away. There are going to be more and more opportunities and challenges and fantastic things that, and it's just a great career, a great sector. As has been said, it's economists and sociologists, as well as incredible engineers, that are really going to help realise everything.
What are you most excited about happening?
Short term, long term?
Both. I want to share your enthusiasm with everybody.
Well,
this energy is amazing.
Yeah, I mean, short term, it does need to be have a reusable launch and Starship. That underpins the changes we're going to see. So I'm really excited about that. I think it is going to be transformational. Long term, I just can't wait to, it is our adjacent economic sphere, a vibrant space economy, where assets interact, things interact in space, not daily, but by the minute. We're comfortable with interaction in space. And I mean, I think it was called Scale. There was a book called Scale I read a few years ago, and it had this sort of theory that everything from the microscopic to the macroscopic kind of evolves in pretty much the same way. It evolves as clusters and connections between those clusters. So I think in the next little while, we're going to change the way we use space completely. We use it in a really stupid way at the moment. We scatter stuff as far as you partly can. We're going to move to these clusters. Clusters are the sort of they're the nucleus of economy. They allow interaction. They allow exchange. Interaction exchange accelerates the numbers game, accelerates the learning, and once you get that in place, some magic is going to happen.
This is exchange of what? Data?
Communications, energy, you name it. Stuff. new biomaterials, but you've got to be close to each other.
Okay, so you're going to power her factory?
Absolutely, 100%.
Excellent. We're going to come to some audience questions in a couple of minutes. Just before that, what have the biggest challenges been that you've faced in doing what you're doing? Katie?
Gosh, so I'd say on a practical level, it's been finding the launch slots to get to the space station, to the ISS. There's been a lot that's been happening and changing at the moment. And for us, we want to go to the space station to de-risk a lot of the other aspects. So getting that launch slot, booking it in.
How do you go about booking it? How far in advance do you have to book it? How does this work?
Yeah, exactly. Just can't, what was it? It's like Skyscanner.
Yeah. Well, that's what I was wondering. It's not quite booking dinner, is it? How does it all work?
So there are platforms that have spaces on the space station. So you kind of go through a middleman company, basically, who then organise your launch for you, in our case, because we want a space on the space station. So they'll work out the slots and then you go through them to book those slots. So there are platforms like that around. But yeah, so I think it's very different for booking satellites, I assume.
Craig?
For me, it was changing attitude. So it's probably okay for me to say this. I'm going to say it anyway. But back when we were trying to kind of pioneer CubeSats, we had some supporters and some people that didn't support us at all. One of our supporters at ESA was dragged in front of the Director General at the time and told never to use the word CubeSat again.
Why was that?
Because he didn't like CubeSats.
Why didn't he like them?
Because it was challenging what they did.
Yeah, challenges the status quo. I mean, what Craig did is incredible.
Yeah, and we had, Lord Willits is here. He was a great supporter of us, and we're very, very grateful for that. We had similar things in the UK too, with the UK Space Agency. It's just was very difficult in the space sector, say 20 years ago. Now we are much more open. In fact, even the MOD is talking about using CubeSats and small satellites to deliver their needs because they realise it's a much quicker way of doing it, rather than a 10-year programme. And once you reach 10 years, the technology you originally started with is now defunct. So there's no point. Right? So you need to move much quicker. And that's what these technologies are allowing us to do.
Anita, for you, what's it been?
It's multifaceted, to be honest. I run a space company, and so it's everything and everything across from, engineering, HR, finance, across everything. But that's why I do this job, right? Because I love building a team, I love growing a company. And so I do it because I love the challenge, and I don't really see anything as a barrier. We've just got to figure out a way to move forward and make a plan to do it and just have that determination. But I just wanted to come back to the STEM point you made, and I really want to make a push for the engineers in the room. I can't leave the stage without talking about this. I think a lot of people think that engineering is a very dry, dusty profession, but when we think about the constraints and challenges that we have in the space industry, it fosters such creativity. Every day you show up and there's a new problem that needs to be solved. And I can't think of a better profession that I'd want to recommend to young people that you could take away when if you've got young people in your lives to talk to them about how really rewarding it can be to just be solving problems every day.
Cool.
And how about for you, Sam?
I think.
Are you going to end on a high? Are you going to refuse to tell me about any challenges?
No, there have been one, possibly two. But I mean, we're kind of in the position Craig was a decade ago, actually. There's a lot of people that their first reaction is science fiction, surely not, and why bother? You've got terrestrial, solar, It's not straightforward, but it's hugely gratifying what we're doing and the steps we're taking. Financing is probably the biggest challenge because what Craig did with CubeSats was amazing, but it was the whole idea was that the cost point was pretty low. You can throw them up. Our cost points, one of the reasons space solar power has not been a thing is because you end up with large systems. And one of the innovations that we've developed is that we can use different orbits, which mean we can have sort of lower cost initial systems. But the world is not set up to finance energy infrastructure full stop, whether it's in space or on Earth. It needs collaboration between public and private finance. But I think we've got a really nice plan now. I'm on this journey because I think space and space-based solar power can have a huge positive impact on the planet. But I'm also 100% confident that the steps on the journey are going to be hugely impactful. So both wireless power transmission for in space, for powering whatever Katie does. I mean, once launch is solved, power is the next constraint in space. but also, you look at the grid issues in the UK. We need innovation in terms of how we move power around. And then assembling large structures in space, and working with Anita and colleagues. It's got so many applications. So it's going to be a great journey, but just come on it.
Well, we've got lots of questions here from a very enthusiastic audience. It's not always like this from audiences, so this is really good.
Great.
How big an impact are the new spaceports in Scotland likely to have on the UK space ecosystem? Craig, I'm going to give that one to you, based on geography.
Well, the launch vehicles in Scotland are going to be smaller, obviously, in the kind of scale of launch vehicle that Sam's talking about. But I think having that ability to have responsive launch and actually the orbits that we mostly use are what we call retrograde, so it's just slightly left of the North Pole, and it allows us to have basically the satellite crosses the equator at the same time every orbit, which means we can take pictures and things like that, and so we can control where the satellite and where we need it to be. So we're in the perfect position to do that by launching north. It will be used for multiple applications. We shouldn't allow SpaceX to have the complete dominance of the market. We shouldn't allow that. We need to have our own capability here. We also can control how green space can be. And what I mean by that is, we talk about all these amazing things we want to do in orbit with these massive structures, but if we continue to throw thousands of satellites up like our pal Musk is doing, we're going to end up contaminating orbits, especially if we accept a failure rate of spacecraft.
Yeah, which is going to bring me on quite tidily to the next question, actually, which is something that always gets raised. What about waste and rubbish and space junk? How can we still be responsible and sustainable and not litter our space? Who wants to take that?
I can, at least Sam and I, but basically we need to deorbit at the end of life, and one of the easiest ways to do that is not to launch into too high an orbit, because it'll naturally deorbit itself. There is some residual atmosphere, there's drag, it brings the satellite down. So even if it fails like from the start, it will still come down within a reasonable time. What we're talking about now is 5 to 7 years, but we have spacecraft up there that are quite large that will be up there for hundreds of years, and they're the problems. And then you've got upper stages of launch vehicles and all sorts of things. So there's lots of pieces up there, but also the space is quite big. So that's why I wouldn't go to space, by the way, because I wouldn't want something to there's too many things that can kill you. But send up
that being the
thing
reason.
with no people in it. That's what I suggest. But we do need to be responsible now, because now is when we're throwing up much more spacecraft. If we're responsible now, then we can avoid the challenges of the future.
Because I guess they cause risk to everything else that gets sent up there as well. So you could have things not work that have great potential.
We've got to strike the balance. So on Earth, we discovered way too late that we need to be sustainable, but there's a sort of balanced scorecard approach where you've got the economic benefits and sustainability, they work hand in hand. In space, we're lucky in a way, insofar as we understand that we need to be sustainable. So we're on it early. However, I'm of the view that you've got to have that balance, and we've got to get good at space in order to make it sustainable. There is a danger we focus so much on sustainability that, you're right, Craig. I use the kids' playroom analogy. We scatter our stuff across this asset as far apart as you can. That's the modus operandi. It's cracking. So you don't use an asset like that. It's impossible to clear up. So I actually think one or two things. One, we need to focus on getting good at space. That involves taking some risks, and it involves allowing this numbers game thing to allow us to get good at space. Once we're good at space, you can make it sustainable. Brilliant companies like Astroscale, it takes them 6 months to even get close to an object. That's not good enough. They're an absolute class-leading company. Second thing is then this move towards clusters, which I think will help us, A, get good at space, but B, you got your stuff in the same place. And then the circular economy. So I think there's a lot of really good thinking coming around from the academics now, where actually deorbiting is probably not that sensible, because of the atmospheric pollution issues. And frankly, once you've expended the energy to get it up there, boom, I think we're going to see a really huge shift, a paradigm shift in the way we use space. And it's going to be very, very exciting.
Fascinating. I'm going to ask you this next, Katie. How do you envision managing the supply chain to support pharmaceutical development in space?
Yeah, sure. Great question. So it's a challenge. So because we want to be manufacturing drugs that are then used on Earth and injected into humans, you have to undergo all regulation like you would with any factory. So GMP regulation, etc. So we have to translate that to a space environment to then make sure that what we're producing hits all of those regulatory points. It's just that your factory is a few miles that way rather than in a different country. So I think one thing I'm excited about is for space to be seen as just an environment. So rather than all of us being seen as space companies, it's like, well, actually, no, we've got an energy company, and then I'm a pharma company that just so happens to use the space environment. So I think we'll shift in time more that way so that we're not all sort of classed in the same bubble, because we're very different and requirements are also very different.
Yeah, interesting change of perspective. Anita, this one for you. Do you expect a skills shortage in this sector? And if so, how do we invigorate interest to help the UK to maintain or grow our position?
This is an area that's been plaguing the UK for a very long time. I mean, the industry is essentially bottom-fed. We're a funnel. And if we don't have enough young people choosing to go into the right education courses when they're young, then we don't get them coming out into industry. The one thing I will say, though, is that not everybody, as I said, as we've all been saying, needs to have a space-related degree to enter the space industry now. And what we're seeing is an increasing influx of talent from adjacent industries such as aviation, automotive, increasingly software, because a lot more of what we do in our spacecraft is software defined. And so it's no longer necessary to have that kind of core, and robotics as well. So there's no need to have that same group of just very small niche skills. We're able to expand that a lot more widely. And as Craig said, you don't have to know space. You can join our companies and we'll help you to understand the specific requirements of the space environment that mean that you need to just have some other considerations when you're thinking about how you design your systems. So yes, there's always this challenge at the moment, but I think we're trying to be inventive about how we acquire that new talent to help us to grow.
Can I use Scotland as an example? So there's pretty much a handful of people working in the space sector when Clyde Space started. Now there's over 6,000 in a country or part of the UK that had no space sector. So, and most of those people didn't work in space before, vast majority. But if you were to ask a company, what staff do you need over the next few years, they'll want somebody with 5 years experience and, you know, in a certain discipline. And that's not the answer. The answer is for us to forward think and say what talents do we need in the next 5 to 10 years and make sure they're coming through the system. So talking to schools, getting them in. We need technicians, we need engineers, we need scientists, we need all sorts. It's not just top PhD levels. Don't think you need to be massively trained to work in space.
I think a related question to this has come in, which may be for Anita. I really appreciate your push for STEM outreach to enthuse young people about their prospects in this sector. What resources can you recommend we all use to keep championing the message and engagement?
Oh, there's a number of different websites. I think if you're a young person in this audience, you go to the student organisations such as UK SEDS and others like that. And all of the main space companies get very involved in outreach. We really see the people in our organisations as the engines of our growth, and we can't exist without them. It's all about the talent and the brains that we bring in. And so most of us are pretty proactive when it comes to outreach. And so a lot of our websites have got a lot of useful information as well. So there's a number of different ways to do that. I'd get out to as many conferences as you can. There's lots of different conferences, some that are relatively low cost or free to attend. And just, start to absorb the environment a bit and start to make some connections and see where you think you might fit in.
Also, as soon as we start launching from the UK, the increase is going in massively. The attention of space, everyone's going to be interested in it. If you've got kids, take them to a science centre. So I'm a trustee of the Glasgow Science Centre, and I love to hear all the kids in there. There's lots of things they can play with and learn about science and engineering, and that's a great way to introduce them to it.
Another member of our audience would like to know, how might we start to see things like AI, edge computing and data centres develop further in space? A data centre in space? Yeah. What thoughts?
I might go with that one. There's a company called Strathclyde, which is building a data centre in space, and they've recently raised a lot of money to do this. So it's really exciting. Again, the the sustainability benefits of having it in space versus on Earth, because on Earth we spend so much energy trying to cool these data centers down, but if you have them in space, then you can save that energy cost. And there are other benefits to it as well. So I think these are really, again, when you say it, it sounds sci-fi, but this is happening now, and these things are being built now. And so I think when you think about, oh, this is really far-fetched, it's going to be a reality in the next 5-10 years. So I think it's, again, that shift in mindset in terms of where the puck's moving. Data centers are not far.
Sam, this is one for you.
AI. Sorry, just continuing on the AI. I think we're looking very much outwardly as well, but I would like to talk about space with citizen as well, and using space for good and using Earth observation. Sam talked about Earth observation satellites and, them taking one image a day. Now we have, or one image a month. Now we have lots of spacecraft that are taking capturing lots of data about what's happening on the surface of the Earth, and it requires a lot of processing power to try and turn that into useful intelligence. And that's where AI, not necessarily in space, but using AI to leverage space-based data can really play a role in helping us to understand more about the planet and the climate.
And for Sam, what technological hurdles need to be overcome to build and operate your first space-powered power plant?
So I can build on the AI thing there. There's, I think it was you, Anita, but someone said, I mean, these are hypermodular systems. They don't look anything like a normal monolithic spacecraft. They're comprised of hundreds of thousands of the same coffee table size modules, and it's all assembled in space. But it's like putting bits of Lego together. I mean, if anyone's interested afterwards, I can show you. So we've got an assembly concept. We've got a nice little video if anyone wants to look at that. We've also started building the robots, and they're not, complicated 6 degree of freedom arms or anything. They're very simple crawler robots that crawl up the structure, build the next bit of truss, and kind of off you go. So it's like taking Amazon warehouse type robotics and putting it in space. So AI and robotics is going to be really key, but it's going to open up so much opportunity. Other technology, you've got the whole wireless power piece, but that was, the sort of glib answer is that was proved at the right sort of efficiencies back in the 1970s. So there's a scale up to all of that, but that's something we're looking at. The rest of it, the good news is that we can use largely today's technology. I mean, there are advances that can then improve the economics as you go on and on and on. There's some amazing research in Cambridge about some of the photovoltaics where you can remove the substrate, make it ultra thin, and your sort of first thought would be, well, that'll make it worse in space. Actually, no, it's really light, and because it's so thin, the sort of path length for interaction smaller is better in a radiation environment. Then at the temperatures we operate at, it self-heals. So there's some amazing things going on that can make it better and better. And I think one of the things I love daily is, we've got robotics people and space engineers and energy engineers all together, and the problems they're solving are brilliant. Actually, how do you build a kilometre scale spacecraft that's actually quite, I need to find a different word, but it's floppy? How do you go about managing and operating that in a space environment? It's absolutely incredible innovations that are being delivered.
And somebody in this room would like to know, how do we deal with cyber risks in space, especially when there's so many different countries involved?
Well,
who fancies answering this?
It's a big challenge. There's a mission that's being built in Scotland at the moment, which uses quantum key distribution. That's going to be the type of thing we need to be using to secure our satellites. At the moment, it's far too easy to hack satellites. I won't say which one it was, but a UK satellite was moved by someone. And that was an old satellite. It wasn't used anymore, but it shows that people were able to hack in. We haven't really been as careful as we should be up until now, but now the satellites we're building these days are much more secure.
And what other interesting businesses or technologies get unlocked with this step change? Things have moved around in cost to orbit. What other interesting businesses and technologies get unlocked with this step change in cost to orbit?
I think to Sam's point around every industry needing to have a position in space means that space can unlock all of the industries. You look at agriculture now and how that's being really powered by understanding better navigation, understanding where, the quality of your crop yields through Earth observation, and having all of those linked together by a communication system. It's kind of all these cross-cutting things coming together, and how you combine them to support each of those verticals, I think is going to be really interesting going forward.
What I would like to see is the big industries like pharma and semiconductor manufacturing actually realise that space is an option for them. They put a lot of money into their R&D projects, put some of that towards space projects as well, because that's going to be the future. I don't think they quite get that yet, and we need to educate them to use space for the future.
What is the general reaction? Katie, when you tell people what you're doing, what's the standard reaction you get from people?
So from pharma specifically, there are questions over, is it scalable? So if we look and we find a benefit in this drug, can it actually be scaled? Is that possible? And so that, again, then have to explain about how space infrastructure is changing and how actually it is possible, thinking about that moving puck. Yes, it is. We're not there right now, but we are moving there. And yes, the scalability is possible. So that's always a question. And then again, over how cost effective is it? And it is when you're dealing with these really high value drugs or high value products. So I think as the step change comes in and the threshold of what it makes sense to make in space will continually start to go down, and more things will then come above the threshold. So I think, we'll start to see some change there.
I'd like to see us actually. I've always been a bit of a skeptic of asteroid mining, but it's sort of come into my head right just now. So I'm going to run with it. So at the moment, what's happened globally is we're currently we're certainly having some heated debates about rare earths, and there's the Ukraine and there's Greenland, and everyone wants some rare earth minerals, and we might even. But we're all having to spend a load on defence just because of all this stuff. Why not put some of those billions that we're about to put into defence, or potentially something worse than that, towards space? Because actually, for probably less than what we're about to spend on those sorts of things, we could get very good at bringing a lot of that stuff back from space. I do think the step on the journey first is to do this large infrastructure to get you good at space, to allow it to go and get the mining. But Starship changes everything. You could put a JCB in a rocket. There's so many things you could just do. It wouldn't work very well, but that's the sort of principle. We've just got to open our minds to what's possible.
Okay, here's something to open your mind to. We have a question. What are the panelists' thoughts about establishing a human colony on Mars?
Well,
It's hard to do.
we have
very
magnetic
hard to do.
fields, and
Yeah.
that's why we're alive. It stops us being fried by radiation. Mars doesn't have barely any atmosphere, barely any magnetic field, so you
It's
need
a
to live
very long way
underground,
away.
basically. So I think psychology is going to be the most important skill, because it's trying to get everyone to not kill each other when they're living underground on Mars and wondering why they went there in the first place.
Yeah,
But
you're not
maybe I'm a
selling
bit
it.
sceptical.
Does anybody think it's a yes?
I wouldn't be tempted by going to Mars, to be honest. It's a very inhospitable planet, and it's a long way. It's a long way to get there, and a long way home if you're even going to come home.
Okay, thank you. The answer's no. Will there start to be...
I think we should. But
Okay, you've got some optimism again, haven't we?
If you want
Are you
to
off
go,
to
you should
Mars?
go.
yeah, no, I'm not saying I'll go myself. I do think.
So you wouldn't go yourself, but you are suggesting other people might.
Why? I think for humanity, it's an important thing. Yeah.
Right.
Yeah.
But not you. No, some other people.
Not today.
No, okay. No, definitely not today. Will there start to be satellites orbiting the moon as we need them for our day-to-day life on Earth? And if so, how will they orbit as gravity is weaker on the moon? Who would like to answer this? Anita, you look
Yes, well, the answer is yes, and they already exist. There are already spacecraft in orbit around the moon. They're mainly there for observation, so that they can map the terrain, and that's been very useful with the recent lunar landings to get a better understanding of what the terrain looks like. And increasingly we'll need more. So at the moment is situational awareness of what the surface looks like, and increasingly we're going to need satellites that can relay communications from the Earth to the lunar environment, relay navigation so we know where we are on the lunar surface. In terms of, what was the second part of the question, sorry?
I'm afraid it's disappeared from here, but it was.
Do
well, we
they
always
operate differently?
Do they operate differently? Well, yes. So gravity on the moon is lumpy, but there are, just like there are around the Earth and around the Sun, stable orbits. There are pseudo-stable orbits that you can operate around the moon. So yes, we will over time see many more spacecraft, because they will be required to sustain the activities on the lunar surface.
Okay, somebody would like to ask about project life cycles. Historically, it's not uncommon for there to be a decade from concept to launch pad. Is the commercialisation of space squeezing this lead time? Now, we were talking when I arrived here earlier about something that was started in the 70s and still hasn't happened.
No, it has happened.
It has happened. It has now happened, finally. We've just got there from the 70s. But is there a chance that things are going to get quicker due to the commercialisation?
I think days or weeks, maybe hours.
Yeah.
So building a platform that can accommodate a payload with the right interface. So you build a platform and a payload that can just be plugged in together, and you could have something to go on a launch vehicle. This is why it's important we have launch in the UK. So if we want to have responsive space, which is important for the future, you would have a bunch of satellite platforms just waiting for the payload to be stuck on, pop up, and there you go.
Yeah, and I would say with that, in terms of how do you enable that, it would be again about standardization, making sure that everything all fits and works and is tested, and then the commercialization of each piece. So again, with how CubeSat's changed the game. So I think for some bigger projects, so like Starship, you wouldn't be able to do very quickly. I mean, but things are happening faster. But I think standardization is something like really key.
And the whole manufacturing piece. Someone mentioned Starlink earlier, but I saw a clip on LinkedIn of the Starship factory, a Starlink factory. It's amazing. 70,000 antenna a day or something, and it's all automated. It is incredible. Incredible.
To check that.
I've got a question here for you, Sam, I think. To solve the critical environment challenges of our planet, we keep setting goals on Earth, net zero to 2050 and so on. But what is the role of space in achieving these goals, and why is it always overlooked in all proposed strategies?
That's a really nice, loaded question. I like that. And I'm going to give a positive answer to it. Yeah, it's great. I mean, I think space is increasingly, awareness of space is not what it should be. I mean, space, through the work of many brilliant people over the decades, it's frankly what made us aware we've got a problem. Already today, with the observation, it gives us the sort of intelligence we need to manage the planet in the way the 21st century needs. We've got all that connectivity and stuff. And I think it is now the recognition that what's going to happen with the new infrastructure that can be put in space, that it can be, part of the future. I mean, my perspective on the challenges that we have on Earth, particularly from an energy perspective, is that we need all the solutions that we've got. We need diversity in our energy system. At the moment, there's a number of different options that may come to pass. We don't know what timescale many of them come in. We certainly don't know the economics that they're going to come in. For my sins, whilst I did a PhD and was used to be able to count and stuff like that, I've done strategy for the last 20 years. And in times of uncertainty, which is absolutely where we are now, writ large, you give yourself options. So we should absolutely be giving ourselves options, and space needs to be part of that narrative. I mean, I think we've actually done quite a good job in the UK. I can see Lord Willits. He's been absolutely the heart of this for over a decade. But we have done quite intelligent things, like I think what it's called the National Space Council, which brought all of the different government departments together because space benefits everyone. But we've got to do more things like that to really make people understand, A, how integral it is to what we do today, and B, what an important bit comes to the future. I was thinking about the Mars bit. I think space is really important for psychology, actually. So you gave the sort of downside psychology point on Mars, which is once you're there, crikey, it's going to be lonely and all that kind of thing. We're born with eyes facing outwards, yeah? We're born to explore, and we're born with, I think for the human condition, the possibilities of being able to do something are really important for human beings. And space gives us the options of possibility, it gives the option of abundance. And I think those are two things that are really worth striving for.
And that's really a rather beautiful end to this panel, as we've just run out of time. Sam, Anita, Craig, Katie, Thank you so much. I think this has shown us great optimism for what's possible in the future, both in terms of exploration and how we can better life for us here. And another takeaway that I will really have from this conversation is the idea of, instead of rounding you up as the space sector, you're working in solar, you're working in sustainability, in energy, you're working in pharmaceuticals, and actually, instead of bunching it all up as space, actually, space is just another place for us to do things. Thank you so much, and thank you very much for everybody who's joined us.